Alright, so first of all, if you ever have to make a shampoo commercial, don't do what I just did and place a cool trap song with some hard cuts in there. Make it look soft and smushy and stuff like that. But I made it like this because my audience mainly consists of males between the age of 18 and 45, and we like the cool stuff, you know, and I'm like that too. By the way, ladies, I see you as well too. Happy to have you here. When I made a community post about the bubbles, a lot of you guys seem to want a tutorial for this. I improved on the original version, so it's even better. I'll also tell you about GeoLights Pro, which is an add-on I made to get the fastest and easiest product lighting out there, but more on that later in this video. You can also download BubbleWorld on my Gumroad for free if you don't want to learn some cool and useful stuff and simply want the final result. So let's get started. So I'm going to delete all of this, add in a plane, then open up a tab right here and go to the geometry node editor. Now press on N to remove this, press on new, and we have group input and group output. Our group input is this plane. So I actually want to explain the thought process behind this before we actually start doing the geometry nodes, because I think it is important that if you actually want to learn how this works, you need to understand the thought process. So I'm going to make a beautiful little drawing, and the first thing that we want to do is we want to have something where we can spawn our bubbles onto. So in this case, I am going to use a grid. This is a grid, and on those grids we have points. These are the points, and on those points I want to spawn my bubbles, which look like this. Very beautiful. And then when we have the bubbles, we also want these bubbles to have some properties. In this case, I want to make it scale in and out to give a cool bubble animation effect. But what I also want to do is add another object that will be able to influence the Z height, or how high the bubbles go, using a geometry proximity node. If we can follow this thought process, I'm going to erase all of this. First, we need to delete the plane. Why? Well, the plane doesn't really have that much points for us to spawn things on. So I'm going to delete it, Shift A, and I'm going to bring in a grid. And a grid is a lot more versatile in geometry nodes, so we can change the size right here, and it's all procedural. So the grid is the better option in this case. What do we want to do? I'm going to add a node called distribute points on faces. Now, as you can see, our original plane disappeared, and we only have those points left. Now, if you don't like these points intersecting, you can set this to Poisson disk and then increase the distance minimum. But I'm not going to do that for this tutorial. It's just a little thing that you should know if you use this node. So distribute points on faces. We have our density right here, which decides how many points are on this face. Now, on those points, we want to add instance on points an icosphere. I'm going to add in an object info node. And then over here, I am going to make an icosphere. Set it over there, click on the plane, and select our icosphere. So now in this object info node, we can use this to spawn on these points. Now, why do I use the object info node? Well, maybe you want to change the objects that you're using. So now we are using bubbles, but maybe in the future you want to use another object like a Suzanne or a cube or whatever. The good thing about this is also that the material we apply on this will automatically translate into geometry nodes as well. So geometry into the instance, and right here we have our very beautiful bubbles starting to exist. Well, the scale is a bit off, so we have our scale value right here. And what I want to do is randomize this scale, because not all bubbles are equal, they are not all the same, so we need some variation in our bubbles. Now, how do we do that? Well, I like them to be random, so I'm going to add a random value. I'm going to keep this to float, and then I'm going to add a map range node. And this decides between what values our scale will be applied. And you will see what I mean in a minute. So plug this value into the value and the result into the scale. By the way, if you use this for scale, a float will be fine. But if you use this for rotation, you need to use the vector, because a rotation goes into all axes and scale actually only applies proportionally. So it doesn't really matter if you use a vector or not. So the float is fine in this case. Now, what do we want to have happen? We have from min and from max. And as you can see, these are very large. So I'm going to change the to max. And now you can see that the maximum value that these bubbles can have is only this big. So it cannot go bigger than this, which is fine. So now we have some randomized bubbles already. Very cool. Now, let me increase the density for now to 20. And we have a plane with bubbles. Now, I want to shade this smooth because, well, you can see the geometry right over here and all these polygons, and that will make it look pretty bad. So I'm going to press Shift A, Set Shade Smooth, which is basically the same as shading it smooth in the modeling tab. So right over here, this looks fine. So what we've done, we've randomized our scale. We have our object that is being instanced on the points of faces that we spawned on our grid. Now, very fine and dandy, but we are not there yet because these bubbles are not animating. And you can see that when I play on the timeline, there are actually no bubbles coming into existence. And that is a problem. So we are going to change that and use the scale instances node. So right here we have our scale instances, which means that we can scale all our instances. That is a good thing. Actually, we did that as well over here. But now in here we can add a different setup so that we can actually change the animation of this. And that's why I changed the scale first over here. And now we're going to change it over here because this is where the animation will take place. We want to add another one of these random values, because I don't want them to scale uniformly like this, because now they are all scaling at the same time and I want this to be randomized. So I'm going to use a random value and then I'm going to add a factor multiply. I think a normal math node would work as well, by the way. So factor math in this case, I found out that this works. So I'm just going to use this value into this one. And now I'm going to make a little bit more space over here, duplicate this multiply node. And I'm going to set this to sine. Now, sine comes from the Latin word sinus, which means curve. So basically it is a curve, it's kind of like a wave. So what a sine looks like, it is basically going like this. So now that we've got our wave, we can add this multiply in the vector and the vector into the scale. Now, as you can see, everything disappears. Why is that? Well, the multiply doesn't really have any value as of yet, and nothing is happening. So what we want to do is manipulate this multiply, and then it will go into the sine wave, which means that it will go up and it will go down, it will go up, it will go down. That means that it's going to scale and then scale back, scale and scale back. So how can we do that? We can add a Shift A, scene time, and I'm going to plug in the frame. And now what do we have? A very erratic looking animation. Let's try seconds. There you go. So seconds looks a lot better already. Frame is way too fast. And we can manipulate this using another node, namely a math node. Math node. I'm going to set this to multiply. And basically what this does is, if this takes a second, well, now we multiply it by half. So now it takes 2 seconds for 1 second to occur, basically. So it will be 2 times as slow. So if we set this to, let's say 10, then you will see it will be a lot faster. So this is the value that we can use to manipulate the speed of our bubbles. Pretty much all right, just going to set it to 2, could be a little bit faster. Yeah, something like this. And right over here, we can add another multiply. And this will determine the overall scale once again. So if you want them to be just a little bit bigger, we do not have to play around with these values or these values. We can just manipulate it over here. And later on, I will add some inputs so you can actually use it in the modifier tab as well. Either way, it's now scaling up and it's scaling down, as we can see. Very good. And one thing I find is that this is not really subdivided the way we want it to. And we can actually just do it right over here. Control 1, and now it looks a lot smoother because we added a subdivision surface modifier on our original icosphere. So this is basically the animation part, and now we have our bubbles moving, which kind of looks like this. Not bad. And right here we can increase the scale. Very good. And maybe we can go over here and set the 2 max a little bit lower, so we have a little bit more randomization in our bubbles. Something like this. And have them be within the same range of scale, let's say, so something that is logical. But you can play around with these values and get different types of results for whatever you need or want, and you can also increase the density and you will have more bubbles. So I'm going to set it to 50 for now. The only thing that we want is to add a proximity node. Why? Well, if we look over here, all the bubbles are on the same line, and this makes it quite a bit harder if we want to add a product in here and make it look cool. So what do? Simple. We're going over here, add a new node, set position node, set position. We use this node in order to offset the position. So you will see that if I increase the z-axis, the entire thing will move up. Now, we don't want this entire thing to move up, so I'm going to do this based on the proximity of another object. So how close is the other object to this plane? And that will determine the way it is moving upwards. So how can we do that? Let's add a sphere. UV sphere right over here, and drag the sphere right over here. And it's set to original, but we want to set it to relative. And basically what this means is that it will operate in local space, meaning that if we change the location of this sphere, it will actually do something instead of just saying this is the sphere, this is the sphere, this is the sphere. Now it will say this is the location of the sphere, this is the location of the sphere. Okay? Geometry proximity right over here. Now it needs a target, and basically the target is this sphere over here. So I'm going to plug the sphere into the geometry proximity, and this will determine what it will do. Okay, so first let's plug this into the distance into the offset. And now you can see it is already doing something, but it's not really doing what we want it to do. Basically what is happening is it is affecting the entirety of this grid. And it looks pretty funny, actually, but we're not going to use it like that. So first what we want to do is add a map range node. And why do we add a map range node? Well, we actually want to determine the fall off of this object's influence. I want to say, hey, it has to be less, or hey, it has to be more. So if I increase the 2 max, you can see this will move upwards, things like that. So actually we want it to be inverted, and I'm going to change this to 1 and this to 0. And now you can see that it is inverted. Well, what you can also see is that it is moving on some weird axis. It's going into a wrong direction, but it will be fixed later on. So we have our map range. I'm going to move this to the right just a little bit. And now we can increase the fall off, because you can see it is very harsh. And I'm going to add an RGB curves. Now, if you play around with this, you can see the object's influence. So how far do we want it to go? Does this need to go upwards over there, or this over there? And this is pretty intuitive, so you have to play around with this in order to get what you like. But it's not there yet, because we want to change this to happen only on the z-axis. So now it's also happening on the y-axis, as you can see, and on the x-axis. But actually we only want to move it upwards. So I'm going to add in a combine x, y, z, plug it in right there. Well, now it's working on the x-axis. On the y, no, we need to work on the z-axis. And as you can see, now that we isolated the z-axis, it works totally fine. So now we can move it upwards, and our bubbles are going into that direction. But as you can see, I find this to be a little bit unrandomized. So it's moving up straight like this. It's almost like a rocket. So we don't want that to happen. We actually want it to go a little bit like this, because they are bubbles and they need to be a little bit more randomized, right? So set position. Let's place that to the right. And I actually want to combine this vector with some random values. The way I'm going to do that is I'm going to press Shift A, vector math. I'm going to place it right over here. I'm going to set it to multiply, because I want to multiply the z-axis over our randomization. The way I'm going to do it is using a noise texture, actually. So we're going to use this noise texture. I'm going to duplicate this multiply node and plug in the color into the vector. Set this to 0.5. Let's see what it does for us. Let's go and move this upwards. And now we can change this vector of the multiply in order to make it go higher or not. And as you can already see, it's starting to be more randomized. So there's some mountain shaping going on over here, and it just looks a bit more wobbly like this instead of going straight up. And that's why we did that. This is not the end yet, because I want to randomize it just a little bit more. Just going to duplicate the set position, add in a noise texture, add in this vector node, add the color to the vector, but I'm going to subtract it by 0.5. Well, the reason why we do that is because this noise texture is stored in a RGB value. You can actually see that if you use it on the shader editor, so I'm going to do that real quick. As you can see, there are RGB values in this noise texture. You can see there's some rainbow stuff going on here. Well, that's because this color operates from RGB values, which also means that it is a vector. So if we go into the geometry node setup once again, we use this vector math in order to subtract it by 0.5, because usually it just goes from 0, 0, 0 to 1, 1, 1, which basically means that it moves in only a positive direction. But we also want it to move in a negative direction. So how can we do that? That is what this vector math node does. So we put it to subtract, vector into the offset, and we have offsetted it, so now it's minus 0.5, minus 0.5, minus 0.5 to 0.5, 0.5, 0.5. So now we actually have negative and positive values to work with from this noise texture. All right, so what does this last part actually do? If we remove this proximity right over here, it now randomizes our entire plane. So if I uncheck this, now you can see it's all very flat and all of these have the same height. So we randomized it but we also have this control to randomize it some more. And you can already see that you can do some pretty cool stuff with this. Some pretty cool abstract animations of bubbles going upwards, for example. And of course you can increase the strength and whatever. And maybe we can do that right now in order to show you how this actually works. So I'm going to add a group input. And now we have an empty socket right over here, and we can change things using this group input. So if you want to change the density, for example, you can place it right over here, and now we have a density slider in our modifier stack. Either way, we can also use this group input to change the height of our bubbles. So now we can use this empty socket to plug it into the max value, and we get a max value right here. So now you can increase the size of these bubbles or decrease it, whatever you want. Very good. Now, if you want to change the names of these, you can press on N, and right here you have a little tab with all the inputs that you've got. So this would be the max scale, let's say. Well, that's just something you can use. You can also plug in the minimum in there. I'm just not going to do that right now. We can take another group input and plug it into the value of our multiply right over here. I'm going to call this time scale. So this will influence the time. If we want to play this, now it's bubbly like so. Influence the time, now it's a lot faster. So you can do that if you like to do that. You can also plug in the object, as I said before. So take this empty slot, plug it into the object, and right now you can select any object you want to be your bubbles. So that is quite handy. Move it upwards. You can see that you can do some pretty funny stuff with this, like moving like so, creating some weird funky looking effects. I'm going to take this, and actually we have done everything that we wanted to do. Of course you can do some other things as well. You can randomize this by going over into the noise texture and animating the W slider, so now it's moving around even more. You can use a scene time for that. Once again, scene time to seconds in the W slider. And now it's very fast, so if you add a math node, set it to multiply, and multiply it by, let's say, 0.1, then it will be 10 times slower. And now it's starting to look pretty interesting, all these bubbles. So 0.05 maybe, and now it is kind of randomized, going everywhere, and that's pretty cool. Alright, so from here on out, the next part of this tutorial will be a bit more messy because I improved on this geometry node setup, which also means that I didn't record it at that time and I've added some extra nodes, etc. But I did want to show this to you guys so you can also get to this final result, because the only thing missing right now is that we cannot move the bubbles on the Z scale automatically. And I really wanted to add that because I think it seems like a great feature to have these bubbles go upwards whenever we wanted to, instead of having to manipulate the geometry proximity object each and every time. Even though the geometry proximity is a great addition to this, I think it's better if we can also just move the bubble on the Z scale whenever we like, and then you can just place a product in there and have the bubbles go upwards and you don't have to do a lot of stuff. So the way to do it is to go over here in our original setup once again. So I've deleted some of these nodes so we can do it again. And basically from here on the setup will start. So we are at the last set position node. Going to add a new set position. Why? Well, we want to influence the Z height once again. So we are going to do practically the same trick, but it's going to be a little bit different because we have to animate it and animate the speed of the Z height as well. Do you remember we have our subtract node right here, which came from our noise texture. And by the way, if you're wondering what is this? Well, I had a group input that I placed all these things in so that you can manipulate all these different values right over here. And there's a bunch of multiply nodes in here as well, because I want all of these values to start at 1. So you don't have to move the slider from 0.05 or something like that. It's just starting from 1, and now it looks natural and it's way more intuitive to use these sliders. So that's why there's a couple of extra multiply nodes in there as well. The subtract node, so that's where we're at. And we have now added a new set position node right over here. So what I want to do is add a vector math node, and I'm going to set this one to multiply. And then I'm going to duplicate it, and I'm going to set this one to distance, because the distance node actually determines a point A and a point B between them. And we are going to determine that point A and point B by taking this subtract node from our noise earlier and plugging it into this bottom value. Then I'm going to take this multiply node and plug it into the top value. So let's add a separate XYZ value into the vector. And now let's also add a combine XYZ, and I'll show you why. So if I drag this Z into this offset, it's moving in that weird direction again, where it takes all the different positions on the X, Y, and Z, but we only want it on the Z. So you simply have to add this combine XYZ and then plug this into the Z, and now it works only on the Z axis. So that is why we added those. And right here, I'm going to move this over to the side. This is what it looks like right now. And in this multiply, we want to add a scene time, have it be seconds. And now if we increase this, you can see it moves upwards. Now, of course, we do not want it to move upwards, but we are not there yet. And now what we want to do is add another multiply node right over here. So I'm going to duplicate that one, plug it right in there. And if we move this, you can already see what's happening. It's moving in the z-axis. But we don't simply want to move it in the z-axis in that fashion, because right now it's like the rocket again. So we want to make this random once more. And how am I going to do that? Well, we're going to add a random value node once again. Random value, duplicate this multiply, vector into the vector, this multiply into that multiply, and I'm going to set this to 0 and this to 0.46. When you play around with this max value and min value, the bigger bubbles will be on top or the smaller bubbles will be on top. And I'm not entirely sure why this works in this fashion, but it works, so that's all I care about. And we want the big ones to be on 0 because we don't want it to enter through our plane. So if we decrease this, it's going through our plane. We don't want that. We always want it to be on top of the grid, so we have more control. 0 on this one, 0.45 or 0.46 on that one. So now it's a little bit higher, and we can also increase this using this slider. So now we can move it upwards and downwards in a better fashion. And the way to do it is to add a group input node and add your own group input value right over here. And then you can see one of these vectors coming to life, but we don't want it to be a vector. So what you do is you add a math node right in here, and don't have this be a vector by pressing N, vector, changing this to float. And now if we manipulate this math node, it will determine or increase the scale of this. So that's basically what we did with this slider right over here. All right, so this is the extra added setup that we've got right now. And there's one more thing we can do. So you can place this distance right over here, set it to 0.3. For some reason, this just looks a little bit better, and that's why I added it. You can play around with these values if you like. Maybe 0.4 also looks pretty cool. So that is something you can do, and you can also just leave it like this, whatever grinds your gears. I think this looks better, so I'm going to add the 0.4. Like so, and have it be like this. Now, if you want to determine the height of this bubble setup, you can add once more a group input, then place a new socket right in here. And now we've got a vector once again. So math node, going to add a math node, set it to multiply it by whatever, 0.1. And in this n, we can change the vector once again, because it should be a float. Float right over here, and you can change the name like C height. So we've got a C height, and now it determines how high this will go, as you can see. Now there's one more thing that we can do, is we can duplicate this multiply node. Let's press on N to move this away. Duplicate the scene time node as well, seconds into the vector right over here. And now we kind of can determine, if we take the multiply, how fast this is going upwards. So this is going very fast upwards, or we can just decrease it and have it not go upwards as fast. So like this, and in that fashion you can determine the speed. So this kind of determines the height. So this is going higher, but this determines the speed. This is how fast they go upwards. And these kind of work in tandem with each other, so it's not like if you change this value, then the speed will go upwards very fast or something. So it will also go higher, but it works together with this one. So just so you know. And I think this part of the tutorial is a little bit more messy because I made it after the actual tutorial because I decided to add some things. I hope you were able to figure this stuff out. I am going to show the entire node tree once more, so you can pause and look at things if you would like to. I'm going to explain it all and just do that for now. So we've got a grid with our distribute points on faces, which has a density slider right over here because we plugged it into our group input, and it goes into the distance on points. Which we have added our icosphere to, which is right over here, and it's instanced. Now then over here I added a bunch of multiply nodes. Why? Because I want this value to be on 1. I don't want it to be like 0.01 or something like that, because it's not very nice and intuitive to work with, and that's why I decided to change it by decreasing the strength of this by 10 times, and now the random value can just operate with normal values. So that's why I added this. Random value, map range, this is everything that we've done already. And I've placed this once again into a multiply to decide some extra stuff about our total size. So we can now increase the total size of the min and max. So the min and max are here divided, but now I want them to be, well, let me just show you. So if we change the min and max, it changes the minimum and maximum size like this. But the total size increases the size of all these bubbles uniformly. So that's why I added that. And right over here we have our set position node, the set position animation. I actually didn't change a lot about it, except for this random value. So I found out that if I place this higher, so the minimum higher than the maximum, then the sine wave actually will not go back to 0. So if we play this, these bubbles are not scaling down to 0. They are scaling down to something over here, and that is the way to manipulate that. You can also play around with that. And here I didn't change a lot actually, so this is basically the same setup. I added some extra multiply nodes once again to get normal values for this modifier, so we don't have to play around with super low values. And I did the same over here. And then we have this setup. And basically this just determines the Z height and the Z speed of these bubbles. So we can now randomly make them go upwards without having to use the geometry proximity object, which still works by the way, so it still has its function. And that's basically the entire node setup. And I'm just going to add a couple of screenshots of this so you can make this entirely if you wanted to. So just in case you wanted to copy this, you can do it now. So, and I also gave these a couple of names so that they are clear. And now we need to do some texturing. So the material. Heading over into our icosphere, I've got it right over here, and we've got our material. I'm going to delete this noise texture, we do not need it anymore. So we have the principled BSDF, and what I actually want to do is use a glass BSDF. Going to set it to 1.333. I think this is like the value for water or something. I plug it into the surface, and now this is a glass material. Okay, it's smooth for now. And I want to combine two different glass materials together in order to get a little bit more refraction and interesting looking stuff. So how can we do that? Well, it's very simple. Transmission, increase the weight entirely. So if we look at this is also some type of glass. If we decrease the roughness, maybe something like so, and now this glass looks a little bit different from this glass. You can see that the refraction is different. And that is exactly what we want. And now I'm going to select the glass BSDF and the principled BSDF, press Ctrl 0, and it will automatically make a mix shader. Now for the factor of this shading, I want to use a Fresnel node named after Augustin Fresnel. It actually kind of means that the reflection changes depending on the steepness of the angle. And now we can use the Fresnel node in order to mix these two together to make it look cool. So how can we do that? Well, I want the bubble's edges to be a bit more different than the inside of the bubble. And how can we do that? I'm going to change the IOR maybe to 0.175, add a color ramp, and now I'm going to set the middle value or the white value to the middle. Going to add a new one by clicking on plus. Set this over here, set it to black. I can play around with this to see what it does. So this is moving the middle part of our Fresnel, which means that on this black part, we will have one of these textures, and on this white part, we will have another of these textures. And this will soon become clear. I will plug the color into the factor and the shader into the surface. And now we have two different glass textures mixed together. And I think we can increase the size of this. So this is actually the middle value. So the glass is the middle and this part is the top. So if I change this to blue, which I'm going to do, I'm going to change this to blue. Now we have this cool blue light effect going over here, which looks pretty nice, but I'm going to decrease the roughness anyway of this glass node. And this roughness, maybe something like this. I can change the IOR a little bit. Going to set it to 1.35. And let's see what that looks like in our rendered mode. We're not going to do it in Eevee, it has to be cycles because these glass type textures really work best in cycles. And now I will actually add an HDRI first to get some reflections. And this can be subtle. I'm going over into the downloads folder right here, create some nodes. And I want to set this to film transparent. By the way, I use the add-on called Easy HDRI, but if you don't have that, you can go over to World, then select this little button right here, select Environment Texture, and then bring in your HDRI like that. Or maybe to this street. Going to decrease the sky strength to 0.1, because I really only want it for some subtle reflections. So I'm going to add a plane, Add a plane, bring it downwards. Take this far edge side, press E, bring it upwards. Then take this, Control B, and give it a slope. Camera, viewport display, passe partout. And now we can actually see something going on here. We have our bubbles, which already look very cool, but we can change the background color. Maybe it's nice to use a emission shader. So you can use the emission, increase the strength, and you can make it whatever color you want. I actually recommend making it a color, maybe a bit more pastel. See, something like this maybe. So let's change the HDRI once more. Maybe we can use Canary Wharf. Now I still don't like the lighting very much, and I'm also going to add a product just to show you guys how this will look. All right, so I've just added a product in here. So we've added our HDRI, but it still doesn't look very appealing yet. Now what you can do is add an area lamp and add multiple ones, place them in the scene and try to get the lighting you want. But I'm just going to shamelessly plug myself right here. I have made an add-on in Geometry Nodes. I'm going to add a plane, add a modifier, GeoLights Pro. So this is what it looks like, and it automatically adds these lights. You can rotate them around. I'm just going to decrease the density on these bubbles for now, 10. And you can rotate them around like this. And maybe you want to test out different lighting setups. So you can go over to the offset lights and place one over there, place one over there, and it kind of moves them around. So as you can see, I can play around with the offset, and it switches these lights around on their position, and you can get very easy lighting setups in a matter of seconds. If you like this, you can also rotate it like so, increase the emission strength right here, make it a little bit stronger. And what I also added, what I really like, is a top light. So I'm going to increase the scale of this. And as you can see, there is now a plane coming into existence. You can increase the light value of this as well. And now we have a top light. You can change the height of this. So maybe it should be closer, or it should be farther away. Increase the emission. We can also change the Kelvin of this. So change the temperature to like 8000, and the temperature of the top light as well to 8000. Now it becomes a little bit more blue. And I kind of like this setup already. We can change the light scale. Maybe they're a bit too big. It's going to make them a slight bit smaller, like so. And I can move those positions around, going over here, the light position. Maybe I want to move this farther or closer to the can. I'm going to leave it something like this. You can also move the Y position of that one. Increase the emission strength. Now bring back some of our bubbles. Density 50. We already have a pretty decent looking lighting setup. Now what I don't like is that it's not high enough. So I'm going into our geometry proximity object and move this upwards. It's only going over here, and maybe you like that, but I want it to be a little bit broader. So I'm going to scale it up. And now we've got a pretty cool hill of bubbles going on right there. Now back into the GeoLights Pro. Rotation, and I'm going to rotate it like so, maybe decrease the scale of this. All right, so this is before the GeoLights Pro and after the GeoLights Pro. I'm going to do an in-depth video about GeoLights Pro pretty soon, but for now you can find the link in the description to my Gumroad, and it is a paid add-on, but it will make your lighting process a lot easier. I want this background, which is now being driven by an emission, to be 0 on the emission, maybe give it more of a saturated pink color in the principal BSDF itself. So something like this. So what we can also add, let's go over here, let's go into this mode for now. We can go into the camera, select depth of field, select our can, and change the f-stop to make some of these bubbles in the foreground a bit more blurry. So let's go ahead and lower this, something like so, and now we have this cool cinematic looking effect. So this is what it looks like in the animation. We've got our bubbles, and remember, we can go into the modifiers and adjust the time scale. Maybe we want it to be faster, maybe we want it to be slower. We can increase the size of these bubbles. Do with it what you like. So I hope you've learned a lot following this geometry node tutorial, and that you've also got your beautiful little bubbles. If you're interested in getting those for free, you can check it out on my Gumroad, as well as the GeoLights Pro. And if you want to become an undeniable force in the 3D space, then I highly recommend watching this video next.